Okay, Braylon, here we go on lesson 23. The title is Equivalent Equations and Additive Property of Equality. So if you want to find your packet and locate lesson 23, that would be great. While you're doing that, I'm going to bump to the bottom here, so watch your eyeballs because it makes you a little dizzy getting down there. Okay, so first thing I want to cover is the equivalent equations part of this lesson. So let me read to you what it says out of the book on page 99. It says that two equations are said to be equivalent if every solution of either one of the equations is also a solution to the other equation. So what in the world does that mean? So if I have two equations, one of them being x plus 6 equals 9, and one of them being x plus 10 equals 13, we can clearly see that x would have to be 3 here, and x would have to be 3 here. So both equations are satisfied when the solution is 3. That means that you are looking at equivalent equations here. So now, when I reread that to you, it will make more sense. It's two equations, which we have one here and one here, that are equivalent if every solution of either one of the equations is also a solution of the other equation. So in this case, 3 is the only solution. We're going to find out later on as we move along in algebra. Sometimes equations have more than one solution. In this case, we have 3 at being the only solution. So that satisfies both equations, and so that means that those two equations are equivalent equations. Okay, so the next part of our lesson, we're going to be talking about the additive property of equality. Additive property of equality. Let me just write that right here. Okay, I'm going to show you an example first, and then we'll talk about what the property actually says. So if you have 2 equals 2, for example, I would have to say, well, that's an equivalent equation, right? That equation shows that 2 is equal to 2, and we know that's a true statement or a true equation. Now, if I took this 2, and on both sides of it, I add 4 to it, for example, I now have 6 equals 6. And it wouldn't matter if I added the 4 to the 2 or if I added the 4 before the 2. Either combination there makes a true statement. 6 is actually equal to 6. So this is where we're going to look at what the property states. And if you want to look at your packet there for lesson 23, it's actually written right up there. Let me go ahead and jot it down right here, though. Basically, what we're saying is what it means is whatever is added to one side of the equal sign must also be added to the other side of your equation. Okay, so what it means is that for any real numbers, if we have A, B, and C, that for any real numbers, A, B, and C, that if A is equal to B, then here's also what is true. A plus C equals B plus C. Okay, and this is, notice, A is equal to B. So if this number and this number are the same numbers, and you add a C to that, whatever number that is, it's still an equivalent equation. Okay, and that's using the additive property of equality. If you add the same number to both sides and A and B happen to be the same already, then you've used the additive property of equality. Okay, so let's look at where we can use this. Let me bump down here to the next page. Let's look at x plus 4 equals 6. Because we can use this property to find solutions of conditional equations as well. Remember, a conditional equation is when you find a solution to a problem. So we're going to we had been plugging in values for x in the past lesson, but what we want to find out today is what is the solution that satisfies this equation. So we can use the additive property of equality to do this. We can subtract 4 from both sides, because remember in algebra, our goal is to isolate x. Okay, so I could actually write it like this, x plus 0 equals 2. Or, as you've seen me do in pre-algebra, I would cross those out because I know that plus 4 minus 4 is 0. So we can eliminate writing that and just bump right to x equals 2. Okay, now we can check this as well. So over here, I'm going to actually check it. I'm going to put in my solution for x, which was 2. So I'm going to put that in, and does that make a true statement? Yes, it does. So 2 is the solution or the root. We realized in the last lesson that we can refer to this as the solution or the root to the equation. In other words, 2 satisfies this equation. So let's look at 23.1 together. The example is x minus 3 equals 12. We want to find out what x is equal to, so our goal is to isolate the variable of x. So we can add 3 to both sides, and we would end up with x equals 15. Now in your head, you can kind of put this back in for x. So go up here and put this 15 in for x. 15 minus 3 is actually equal to 12. So it does satisfy the equation, the original equation. And also, I should probably make a note that when we say x is equal to 15, what is actually happening is we're saying that this equation, x equals 15, because that is an equation after all, isn't it? There's an equal sign right here. We're saying that this equation is equivalent to the original equation, which is right here. We're saying that x equals 15 is the same equivalent equation to x minus 3 equals 12. Isn't that interesting? All right, let's look at 23.2. Here we have x plus 1/4, so we can use fractions. We might see problems where there are fractions, and we could solve this using the same methodology. So if we subtract a negative 1/4 from both sides, that isolates our variable. Now I have negative 3/8 minus 1/4, but I'm going to go ahead and change this to 2/8 and negative 2/8, or minus 2/8, and I would end up with a negative 5/8. 23.3, maybe I can include that right here. Oh, this is a little bit longer one, but here we go. Okay, so we have k plus 2 1/3 equals 2/9. And I'm going to subtract 2 1/3 from both sides, because that will isolate the variable. And I have 2/9 minus, and I'm going to change this to, I should have made this, I'm going to go back up here and make this an improper fraction. This would be negative 7/3. But I want to change that 7/3 to something over 9. So I would have times 3, I would have 21. 7/3, right? Multiply both those by 3, and I get 21/9. So here I get k is equal to negative 19/9. Okay, and that is basically the entire teaching, but let's go back up here to lesson 23, and we'll do the practice problems. If you want to do this on your own, you can pause the video and then come back and check your answers. Let's look up here really quickly before we start that. Actually, I see here, let's go ahead and take a look at these problems that are up here and complete these. So to figure out what x is equal to, we can subtract 5 from both sides, and we have x equals 4. On this one, we're going to add 3/4 to both sides, and you can do this in your notes along with me. We get y equals 5/8 plus, we're going to go ahead and change this to 6/8, and you get 11/8 here. And there's your two answers. Okay, now the practice problems, you're going to find those on Page 101, there are 4 of them. The first one is x plus 5 equals 17. So we'll go ahead and figure out what this answer is. We have x equals 12. Letter B, we have k minus 27 equals a negative 38. We're going to add 27 to both sides. Remember, we use the inverse operation or the opposite operation, or we're just trying to get rid of the minus 27, so we do the opposite to make 0. We add that 27. So we have k equals, I have opposite signs here, so I have to subtract these two, take the sign of the larger, and I get a negative 11 here. Letter C, x minus 1/2 equals 3/8. We want to isolate the variable, so I'm going to add a half to both sides because that would give me 0 here. And let's change this to something over 4. We did what? I'm sorry, over 8. That's messy. We multiplied by 4. We get 4/8, so it's 3/8 plus 4/8, and we get 7/8. And then finally, letter D, we have D plus 4 1/7 equals 3 1/6. Okay, so we want to isolate the variable, so we want to subtract now 4 1/7 from both sides. Gives me 0 here, so I have D equals 3 1/6. I might run off the paper here. Let me write this a little bit bigger. Expand this. There we go. 3 1/6 minus 4 1/7. And I'm going to change these. First thing I'm going to do is I'm going to make these into improper fractions. So I would have 19/6 minus 29/7. And then I want to change these to the same denominator, which is going to be 42. And we have to see how we did that. I multiply by 7 here. When you do that math, you're going to get 133. Here I multiplied by 6. And you end up, when you do the math there, you get 174. And your final answer is going to be negative 41 over 42. So in this case, here's your answer. D is equal to negative 41 over 42. Okay, that concludes the lesson today. You can go ahead and work on the problems that are assigned in the packet, and we can address any questions you might have at a later time. Okay, Braylon, have a great day. Thanks for watching.